In lesson 7 of our basic electrical series, we're going to talk about capacitors. This is a relatively short video because capacitors are actually one of the simplest tools any HVAC technician is going to deal with. Okay, it's the simplest of all electrical devices encountered daily. Capacitors store electrical energy, they block the flow of direct current, and they permit the flow of alternating current with a phase delay. Basically, what happens is every time the AC crosses zero, remember our sine wave? Every time the AC crosses zero, the capacitor will discharge with a delay. Okay, so again, with a delay, it will discharge. Capacitors are measured in farads, or most often in HVAC, microfarads. A capacitor with no current running to it will eventually equalize or discharge. Capacitors can be discharged intentionally by shorting the two terminals together. Capacitors cause capacitive reactance or resistance that is caused by the capacitor. We have 4 types of capacitors. Fixed capacitors, they're not adjustable. Electrolytic capacitors only work in direct current applications. We see them on circuit boards. Variable capacitors have movable plates that can be adjusted. Our 4th type is a start and run capacitor. Okay, they are fixed capacitors. These are the ones we use and worry about the most. Start and run capacitors. That's what we're using in HVAC. The start capacitor is rated from about 50 to 300 microfarads. They most often have a bleed resistor, that's a little resistor between the two terminals, and they're mostly encased in plastic containers. They're taken out of the circuit by a potential relay or switch after the motor starts. They'll have a fuse hole in the top for safety. So this is an example of a start capacitor. Okay, we have two sets of terminals there. We have the fuse hole. Now this one doesn't have a resistor, but if there was a resistor there, it would be right here between the two terminals. Okay, if you look at the label, you'll see that this one is rated between 189 and 227 microfarads. And it can handle voltage 220, 250, but we'll talk about that because that's not actual line voltage we're worried about. The run capacitor has a rating between 5 and 60 microfarads. It's often encased in a metal enclosure, 99.9% of them. They're rated with either 370 or 440 volts for the most part. These stay in the circuit once the motor's started. Okay, they don't get pulled out of the circuit. That's why they're called run capacitors. The entire time the motor's running, these are in the circuit. This is an example of a run capacitor. Okay, 2 sets of terminals on the top. Okay, every one of the actual pins on this terminal, as long as it's on the same side of the capacitor, they're all joined together. It's good junction points. If you look here, you can see it as well. There's one set of terminals. There's the other set of terminals. Okay, we have 40 microfarads on this one. And this is a 440 or 370 volts. Again, that's not your actual input voltage. This is generated voltage. We'll talk about that in a few minutes. Capacitors in parallel add their values. In other words, if I put a 50 microfarad and a 60 in parallel, their value will come to 110 microfarads. Capacitors in series decrease their values. So a 100 and a 100 in series will be a 50. Okay, so capacitors work exactly opposite resistors in series and parallel circuits. Knowing this can sometimes get a technician out of a bind in an emergency service call because you can make the correct value capacitor by putting either 2 other capacitors in parallel or series. Do not ever measure voltage on the start winding after the capacitor. The voltage at that point won't make any sense. It's out of phase and it will look much greater than it actually is. By the way, that's the voltage reading that's on the capacitor. The correct way to check a capacitor is to take it out of the circuit and check it with a capacitor checker. We used to use ohm meters here, but that's really no longer valid. Okay, to make sure it's disconnected, then short the two terminals together with an insulated screwdriver, pliers, or preferably a bleed resistor. With a good capacitor checker, you can get a reading that you can compare directly to the label on the capacitor. If it's out of the rated tolerance, replace the capacitor. Don't mess around with capacitors that are out of tolerance. It's not good, and it will eventually lead to burning out motor windings. You can replace a 370 volt capacitor with a 440, but not the other way around. You cannot replace a capacitor of any value with another value. In other words, a 50 cannot be replaced with a 60. However, you can add them up in series or parallel in case of emergency repairs. Just make sure everything's secured. Dual capacitors share a common terminal and have two separate load terminals. Make sure you get the right lead on the right terminal. One is marked Herm for the compressor. One is marked Fan for the fan. The label will look something like 40/5. The 40 is the H terminal and goes to the compressor winding. The 5 is the F terminal and goes to the condenser fan motor. You can replace a dual capacitor with an identical value individual capacitors if needed. Just make sure they're secured and not just hanging by wires. These are examples of dual capacitors. Okay, again, we have three sets of terminals on the top. We might have our common, our compressor, and our fan. There's more than one pin on each set of terminals because, again, we can use these as junction points. And if you look here on the label real close, okay, it will say like 40 and 5. That tells you it's a 40/5, 40 on the compressor side, 5 on the fan side. So again, capacitors you're going to see almost on every AC motor other than the shaded pole, okay? We're not using a ton of split phase motors anymore. So AC motors other than split pole, you're going to see capacitors connected to. ECM motors do have capacitors, but they're internal to the board, to the control module. And we're not talking about ECM motors in this presentation. ECM motors will not have a separate capacitor. It's a DC motor with a control and a rectifier circuit. We'll talk more about that in the future. So again, in this video, really want to get the concept of start capacitors, run capacitors, and dual capacitors. Hope you enjoyed.